Alright, and welcome to 7-3.5, mixed review number 1. Now in problem number 1, it says find the length of DE, and so let's notice something here. Let's notice that here is DE. And so basically we know that we have a chord and a diameter here. We know that this line goes through the center, so that is a diameter. And then of course we know that this one does not go through the center, so that one must be a chord. Now, notice something. This line right here is a radius. This 12 is specifically a radius. So if the radius is 12, that means that from A to B is also a distance of 12. And why is that so important? Well, that's going to tell us that, hey, you know what? If AB is 12 and FB is 4, then we can do 12 minus 4 and understand that AF, this little segment right here, is 8. Okay, and now that we filled in that 8, we can now begin this problem. Remember that whenever you're multiplying or whenever you're solving a situation with chords and diameters, you're always doing the part times the part. So for example, here in the middle we have DF. Let's just go ahead and write out our little statement here. DF times FE, so it's part 1 times part 2, is equal to, I'm going to do this other one in purple, looks like CF. Notice that I'm going this entire length here, CF, times FB. Now let's go ahead and plug in everything that we know. Well, DF and FE are easy. That's just x times x. And by the way, let's just simplify that. That's x squared is equal to. And over here, CF, this is the tricky part. Why did we need to know this 8? Well, we needed to know that 8 because CA is 12 and AF is 8. And what is 12 plus 8? That would be 20. So we really have 20 times FB, which is 4. Now 20 times 4 is of course going to be 80. So here's what you need to do. You need to solve for x, and whatever x equals, you then need to say, well, you know what, DE is actually equal to x plus x, or we could say 2x. And so basically whatever you get for x, multiply by 2, and you'll have the length of DE. Alright, let's move on to our next problem. Okay, problem number 2. Find the area of the regular polygon below. So the thing you want to do with these is you always want to draw the center, and you want to go ahead and divide it up into its triangles. You know, basically kind of like drawing spokes of a wheel. And notice that going all the way around the middle is 360 degrees. And how does that help us out? Well, that tells us that if we were to do 360 divided by 6, the number of central angles, so there's 1, 2, 3, 4, 5, 6, we would say that that is 60 degrees in total. Now, why is that helpful? Well, the reason that's helpful is because what we're always trying to do with the area of a regular polygon is create a right triangle. And we do this by drawing the apothem. So there's my right triangle. And what do we know about the apothem? It cuts everything in half. That tells us that this little half line right here will be a length of 3. And this overall angle of 60 divided by 2 gives us an angle of 30 degrees. So over here to the right, I'm going to draw the triangle that I've just created. I'll draw it a little bit differently than we typically do. Just so happen that I drew it like this, where this side is 3 and our angle is 30 degrees, which means, by the way, if this is 30 and 90, this one has to be 60. It's actually our right triangle. And notice, if this is our right triangle and this 3 right here is the short side, well, we actually know what the apothem is automatically. The apothem must be 3 square roots of 3. So remember our rule for a special right triangle, a 30, 60, 90 triangle. If that's 30 and that's 60 and that's 90, then we have x, 2x, and our third side is x square roots of 3. Alright, well, how is this helpful to us? Well, the reason this is helpful is because now that we know the apothem, we can actually find the area. The area of a regular polygon, so I'll just write area regular, is going to equal 1/2 the apothem times the perimeter. Or if we're going to put this in a calculator, I just put 0.5 times our apothem, 3 square roots of 3, times, here let me delete this so it's a little bit nicer and neater, times our perimeter. Now, you should know how to find the perimeter of a shape at this point. So I will leave you to finish this problem on your own. Okay, problem number 3. Find the area of the composite figure below. Well, notice something. What we have here is we have a semicircle. And we can quite clearly see that the radius of this semicircle, the radius r, is equal to 2. And we know that the formula for the area of a semicircle is equal to pi r squared over 2. Down here, we have a parallelogram where we can see, let's switch colors here. We can see that it has a height of 2 and it has a base of what appears to be 4, a base of 4. And remember, the formula for a parallelogram is the area of a parallelogram is base times height. Alright? Let me write this really nice and neat over here to the right. We have the area of our semicircle is equal to pi r squared over 2, where r is going to be equal to 2. And we have the area of our parallelogram is equal to the base times the height, where our base is 4 and our height is 2. Alright, you should be able to do this on your own, and let's go ahead and move on to the next problem. Okay, problem number 4. The right triangle below has been dilated by a factor of 4. Find the area of the new image. So I first want to start with my dilation formula. We have here, let's switch colors, we have here the new volume, or V new, is always equal to V original times the scale factor raised to the number of dimension changes. Now remember, when it's area, you're changing 2 dimensions. Whenever it's area, you're always changing 2 dimensions. Okay, and so the first thing that we're gonna have to do, so if we're gonna take this formula here, we could just say this. We could say, well, V new is equal to, I don't know the original area, but I do know the scale factor is 4, and since it's area, we're changing 2 dimensions. I need to know what is V0. Oh, I'm sorry. Real quick, we're going to make one slight change. It's not volume in this case, it's area. It's not volume, it's area. And once again, it's not volume, it's area. My apologies. Okay, so we have to know what is the original area. Now, how are we going to find the original area? Well, this is clearly a trigonometric situation. So first, we'll start by labeling. We'll circle our relevant angle, label our adjacent, and by default label our opposite. Now, if we're trying to find the area of a triangle, it looks like it's 1/2 the base times the height. Well, we don't know the base or the adjacent side, which means we really don't care about the hypotenuse. Okay, so in order to find this area of the triangle, we're going to have to first use a little bit of trigonometry. So let's go ahead and set this up. We know that we will use, let's switch colors here to a different color. We know that we will use tangent theta, which is equal to the opposite over the adjacent. Let's plug in everything we have. We have the tangent of 36 degrees is equal to 6 over x. And from here, this is where I'm actually going to stop helping out. So here's what y'all are going to do. I'll kind of give y'all the cliff notes. You are going to solve for x. Tangent 36 equals 6 divided by x. You're going to solve for x. Then you're going to take that x. X is really the base. You're going to plug it in. So for the area of our triangle, it'll be 1/2 times whatever you find for x times the height, which was 6. And then whatever we find for the area of the triangle, we're going to plug in right there. And and we'll do the area of the triangle times 4 squared, and that will give you your new area. Alright, let's move on to our next problem. Okay, problem number 5. I bet this one goes a little bit quicker. Find the measure of arc CD. Okay, so we want to know the measure of that guy. And notice that this 126 is not really lined up with arc CD and arc EB. We really need those angles right there. Well, we're in luck. We know that this line is a straight line, so we can simply do 180 minus 126, which appears to be 54 degrees. 54 degrees. And now we see that we have a vertex that is inside, and so we can do the measure of angle 1 is equal to 1/2 arc X plus arc Y. So remember, this plus is a plus whenever we're using a vertex inside. And so of course our angle right here is 54 degrees is equal to 1/2 parentheses. This is clearly larger than 54, so that must be our arc X plus arc Y, the arc that we don't know. And if you'll recall, there is a trick to getting rid of 1/2. What's our trick for getting rid of 1/2? Alright, well that concludes this one, and I'll see you guys in our next video.